All right, we're probably gonna get started, and if people join late, they'll probably still catch most of the slides, and so they'll give everyone an opportunity to ask questions. Um, so yeah, we're gonna get started. Hello, good morning, everybody. Welcome to another Green Energy Series webinar. Today's talk will be about induction cooking. My name is Edward Louis. I'll be your host and the presenter for today's webinar. So a little bit about Solar Oregon. Solar Oregon was founded in 1979. That would, if you do the math, make us 46 this year. It was founded as a member-based nonprofit that grew from grassroots efforts to support clean and renewable energy. So we support clean and renewable energy through education, outreach, community, and advocacy. So some of the things we do is we do solar tours throughout the year. Here's a photo of a tour of a agrivoltaic facility in Oregon. We toured this a few months ago during the solar winery tour. We also do quite a few how to go solar plus storage webinars, and we do them both as a webinar or in person. And the in-person presentations for this how to go solar plus storage presentation is done throughout Oregon. So we have two staff that travel throughout Oregon to give this how to go solar plus storage webinar. We also do occasional solarized campaigns, and these are uh, neighborhood level organizing multiple homes within a neighborhood to go solar at the same time. And as a result, when that occurs, the cost of going solar is reduced. So there's all the soft cost of doing a solar project is reduced, and so that ends up reducing the cost to the homeowner for going solar. We also do many peer-to-peer education events, such as this Green Energy series. And so, again, you're encouraged to ask questions. Feel free to put your question in the Q&A or chat. I will, at the end of the presentation, monitor and check the Q&A and chat for questions and answer them. So, a little bit about me. During my Monday through Friday day job, I work at Pacific Northwest National Laboratory as a building energy efficiency research engineer. You can also find me on LinkedIn. I post a lot about my latest projects, both at work and outside of work. Um, some of my hobbies outside of work involves testing energy efficient technologies in my home and the home of friends and family. So if reach out to me on LinkedIn. I might end up reaching out to you and picking your home to do some research project, either officially for work or a little side project, research project. And then I'm also working on completing an off-grid zero energy tiny home. Little disclaimer, the views in this presentation do not necessarily reflect the position of Pacific Northwest National Laboratory, U.S. Department of Energy, or Solar Oregon. Best effort has been made to convey facts and information accurately. However, you're encouraged to do your own research and do your own calculations before making investments. So with that disclaimer out of the way, the topic of today's talk is induction cooking. Um, Very, very interesting technology. I think it's the best cooking technology available, and I hope to convince you of that as well in this webinar. We're going to begin in this webinar with an overview of what it is and how it works. It's actually a little bit more complicated than you would expect. When I started learning this stuff, I didn't realize it was that complicated either. But hopefully, the explanation will give you a great understanding of how induction cooking works. We're going to talk about the pros and cons of induction. We're going to also discuss features to look for, new features in induction, and then end with some summary and conclusions. So, induction, how does it work? Well, the simple answer is it's cooking with electromagnets, and that electromagnet uh, excites the metal molecules in the pan and then makes those metal molecules get hot. And so that is the simple answer. if you want a more complicated and actually accurate and detailed answer, this is it. So there's actually three heat generating phenomena that are going on in an induction system. So it involves power electronics. So these power electronics uh, create alternating electromagnetic fields through the coil inside the induction the cooktop. And so this alternating electromagnetic field, what it does is that when you put a cookware on top of it, this electromagnetic field then induces what's called eddy currents in the magnetic cookware. And these eddy currents, when they go through the metal of the cookware, well, the metal in the cookware is not perfectly conductive. And so when electromagnetic currents go through that metal in the cookware, um, if that cookware metal has some resistivity, then this current going through it will generate heat. And the way I think about this is, if you have a stream with some rocks and boulders in the stream, the energy of the stream is kind of like this current, and the like a stream, it's not perfectly smooth. You got stuff inside the stream that's acting as, resistive kind of properties of that stream. And as this river of water goes through the stream, these boulders and rocks takes up and eats up some of the kinetic energy out of the stream, and you get some eddies in the stream also. So there's some parallels to that analogy. And pans that have are made out of material that's ferritic or ferrite or iron based uh, have fairly high resistance compared to a copper or an aluminum cookware. So that's why generally those are the common induction compatible cookware. Um, Now, there's another effect, which is the skin depth. And so, how this works is that as the electromagnetic alternating frequency gets higher, um, like our household alternating current is 60 hertz. Now, if you go to a higher frequency, like 20 kilohertz, what happens is that at these higher frequencies, there's a property called the skin effect, where the current flowing through the cookware, instead of going through the entire cross section of the base of the pan, um, that the current, instead of going through that cross section, it only goes through the surface, a very thin surface layer of that metal. And so this as this skin depth is reduced, then what happens is that the energy going through this pan is now concentrated through a smaller cross section of metal. And so, well, naturally what happens when you have higher current going through a smaller cross section of metal is that you end up heating that metal up some more. No surprise. Um, and so that also increases the amount of heating that goes on in the pan. And then the last phenomena is that the ferritic or iron crystals um, in the pan, these molecules, as this through this alternating magnetic field, it magnetizes and demagnetizes over and over, and these molecular movements in the metal structure causes the friction within the metal molecules, and this friction also generates heat. Um, and this phenomenon is called magnetic hysteresis. And so, with these three heat generating phenomena working together, that's how you can quickly use an alternating electromagnetic field to make a pan very hot, but without making anything else on the cook surface hot. Um, and so, uh, the other thing kind of to note about this slide is that um, not all three generating phenomena in the cookware needs to happen. simultaneously in order for the cookware to get hot. So, like, if later we're going to talk about pans that are not ferromagnetic, so certain types of stainless steel pans, copper and aluminum pans traditionally are pans that you cannot stick a fridge magnet to the underside and have it stick. These non-ferromagnetic pans uh, do not have the heating effect of the third phenomena, this magnetizing, demagnetizing uh, the metal molecules in the pan, but they can still get hot using the first two phenomena. And so that's why I'll discuss later that it is actually possible to, in certain, if we have the right power electronics and the right frequency magnetic field, to get non-magnetic stainless steel, copper, and aluminum to work on induction. So because all this energy is going straight into the cooking material of the cookware, induction is the fastest way to heat up a cookware. And additionally, the heat is all going into the cookware, and none of it, or very, very little of it, is going to the air. So you're in the summertime, you get a benefit of, reduced air conditioning energy use and a more comfortable kitchen. Um, Gases and electric resistance glass top are ones that are notorious for heating up your kitchen. Um, if you can see in the picture that, like, this flame, even if you get it just right, you still get a significant amount of heat going not into the cookware but into the air. Typically, about 50% of the heat in a gas flame makes it into the pan. The other 50% does not, and so hence you can have a very high powered gas burner, but if only 50% of that heat makes it into the cookware, then is it really that high? You do the math, and then you might discover it's actually not that high in terms of effective heat going into the pan. Um, and there here in the lower uh, figure is showing some uh, times it takes to boil the same vessel of amount of water in the same size pot. You can see induction is a lot faster. Another advantage of induction is greater precision. Um, Many inductions have 10 cooking settings, but then it's actually not difficult to find induction cooktops with 20 or even 100 power steps. And so when you get to ones with 100 power steps, you're talking about, 1 Fahrenheit levels of adjustment. Does your cooking in your kitchen need that level of precision? Probably not. I mean, I have an induction range myself, and mine only has 10 settings, and I'm more than happy with the 10 settings. It works just fine. But this is the kind of precision that you just cannot get with a gas cooktop or a electric. You won't find ones with this many power settings. Um, Additionally, many induction ranges and cooktops have some other interesting features, which is, like, for example, you can set them to be on a timer so that it'll cook at 350 degrees for 7 minutes and then shut off. You can program and then have all these additional features. Another thing about precision is it's not just about the steps, but also how how low the lowest step is and how high the highest step is. And so induction has often very good, very low simmers, and that low simmer and low heat is often lower than you can achieve with electric resistance or gas cooking range. And then, as I was saying before, that effective high is often actually higher than electric resistance and gas because, if you have an 1800-watt induction cooktop, almost all 1800 watts is going into that cooking vessel versus with electric resistance, it might be, 70% going into that cooking vessel. And then in gas, it might be 50%. And so that's the effective high is generally higher. Um, Another advantage is safety. Um, so as I was saying, if all the heat is going to the pan, one of the great things is the cooking surface stays cooler. Um, this is a picture of how I commonly cook breakfast. I put all the cooking ingredients like really close to the pan, and I never worry about a plastic Tupperware melting or some paper catching on fire. Um, it just doesn't happen because the cooking surface adjacent to the cooking vessel stays really cool. And it's just really convenient to be able to put things closer within arm's reach, not have to turn around or go somewhere else in the kitchen to grab things. And then in fact, the cooking surface stays cool enough. I'm not saying it's cool to the touch, but it's cool enough. Even if you're searing a steak or salmon right afterwards, you can take that pan off and put a glass serving plates or dish right on top of that cooking emitter um, that was just on high, and it will not damage the glass serving dish, and that's because the the emitter is heating up the pan and not actually significantly heating up the glass top. Um, and this also translates to a significant reduction in the chance of a serious burn injury and a reduction in chance of a fire. Um, in a later slide, we're going to talk about, the price of induction ranges and cooktops. Um, and a common cited con is that they're expensive, and I'll show you that it's not really that much more expensive. And it depends on, it's hard to value safety. How do you put a number on the value of increased safety? But you'll see that the price difference is not that big, and I would try to convince you that, like, with those small incremental additional cost, that it's worth this additional safety. Okay, we also have induction has been found from multiple research studies to result in better kitchen air quality and better indoor air quality. Um, this is there was a study in 2015 by Lawrence Berkeley National Laboratory. They used laser particle scanners to measure the number of ultrafine particles emitted from different types of cooking um, in the home, and these ultrafine particles are so small, zero point 0.1 microns or smaller, that the nose hair and mucous membranes of our noses cannot filter them. So they do go deep into our lungs and then go into our bloodstream. And these ultrafine particles, they measured homes with induction, homes with electric resistance, and homes with gas. And this is the average of what they found in the homes. If you have an induction cooktop, um, the amount of ultrafine particle generated during cooking is about 99% less than the amount of ultrafine particles generated from electric resistance and gas. And these ultrafine particles are generated. The reason why it's so high in electric resistance and gas is because of the ultra high heats from those cooking technologies compared to induction. Um, and that heats up the air and heats up the metal, and then that ultra very high heat results in the generation of these ultrafine particles. Now, okay, well, what are the health effects of these ultrafine particles? Well, that remains a little bit of a area of research. It's not super well known what happens to the human body from long-term exposure to ultrafine particles. Another thing is commonly that there's been many studies on the indoor nitrogen dioxides from gas cooking. Um, and so the EPA has a 1 hour exposure standard for outdoor exposure to nitrogen dioxides. This is mostly for as a worker safety health number. There's actually no indoor residential, safe set limit. Actually, there's no such standard, but we can take this, outdoor limit and use that as a benchmark, and that is at 100 parts per billion for NO2. And in the East Coast study, they measured hundreds of homes with gas cooking appliances to see what the indoor nitrogen dioxide readings are, and 63% of them have readings above 100 parts per billion. So if this was in a work environment, this would be considered not good. So um, a reason to maybe consider moving away from gas cooking. Um, because the cooking surface doesn't get as hot, you really don't burn on food onto a induction cooktop compared to a glass over electric resistance um, cooking surface or a gas or electric resistance element cook surface. This is a picture of my induction cooktop after 1,700 days of cooking. It still looks pretty good in my opinion. Um, and I've never had to scrub hard to clean it. Just, a damp kitchen towel and wipe and it's done. So, I think if you are the person responsible for cleaning after cooking in the kitchen, you might appreciate induction because it makes your job as a cleaner a lot easier. Um, and then my previous cooking technology in my kitchen was a gas stove, and I did not appreciate, trying to clean all those non-flat surfaces, all the nooks and crannies, having to clean up. I really appreciate the smooth cook surface of induction. Now, some of the commonly cited cons for induction, there are many. Um, One common cited con of induction is that the different cookware with different metallurgy will heat up at different temperatures, and that's annoying because then you have to remember, okay, well, what setting to put on this pan versus that pan. Um, that's not really true anymore. There's technologies built in modern induction cooking ranges that measure the temperature of the pan, and we'll get into that. Some say that well, induction results in uneven heating of the pan. Um, that is true. There are ways to solve that, and I'll discuss that. High upfront cost is a commonly cited con. We'll look at today's prices for comparable cooking ranges. Um, Cookware compatibility, so like not being compatible with pans that are not magnetic to a fridge magnet. Um, I'll discuss technologies that are currently new to market here in the US, but I hope that it will continue to gain traction. And then these all metal induction te cooking devices. Um, Others say that it's not good for woks. Well, I'll discuss that even Panda Express uses induction for their woks, so there are many very good induction emitters for woks. And some say, well, with gas ranges, you can cook if there's a power outage, but you can't do that with induction. Well, there are products out there with batteries built into the induction range to make that a possibility. Um, if you're upgrading from gas to electric, the high powered circuit needed to power a induction cooktop or range is, some would say, expensive to upgrade the home's electrical system to accommodate an electric induction range. But there are products with battery buffers, so you just plug it into 120 volts and you're good. Another commonly cited con is that if you cook with induction, then you're going to hear buzzing and hum noises coming out of your cookware, and it's very annoying. Um, I'll discuss how that's not always true. Um, some say induction is unreliable and expensive to repair. And I'll discuss how the failure rates are not actually high. Um, and some people like to char tortillas and peppers on an open flame and cite, well, one of the cons of induction is you can't do that anymore. Well, I will discuss where the induction ranges have an electric oven broiler, and you can actually just use the broiler and get the same results. Some say, well, with gas ranges, you have physical knobs, and then induction, you get touch screens and touch buttons, and therefore I don't like it. Well, there are many models with physical buttons, induction ranges, and cooktops with physical knobs. So let's kind of dive into these a little bit further. So, induction cooktops use uh, one or multiple methods to sense the temperature of cookware. Um, the three most common technologies is one is a thermistor or electronic temperature sensor that's pressed up against the underside of the glass. And so then when you put your cooking vessel onto the uh, induction coil, then as it heats up, then the heat from the pan will then conduct through the glass surface onto this temperature sensor, and then it'll measure the temperature of the cookware and then adjust the power of the coil accordingly in order to deliver your low, medium, or high setting. Um, Another technology is an infrared sensor that looks through the glass and then looks at the underside of your cooking vessel and use that technology to determine the temperature of the cookware and again adjust the temperature, I'm sorry, the power delivery of the coil to achieve the desired temperature. And then still some will have a electronic temperature sensor, a thermistor, uh, and there's a hole in the glassware in the glass top to directly so that the temperature sensor can directly contact the cookware to be able to get the most accurate reading. Um, so all three different methods are pretty good at sensing the temperature of the cookware. So, there may be induction cooktops in the past that had unreliable um, temperature sensing methods, but the modern induction cooktops and ranges use these technologies and they achieve pretty consistent results so that, one cookware to another on the same setting, you still get the very similar temperature in your cookware, despite being in different brand or sized cookware. Now, another con, like I said, was the evenness of the heat. Um, this is not a problem just unique to induction. If you have a large pan and you put it on a small electric resistance heating element on a electric stove, you will get uneven heating. Same thing if you put a large pan on a small flame in a gas stove, you'll get uneven heating. But somehow, this is like particularly cited as a problem with induction. Um, I think the reason why it's commonly cited more as a problem with induction is because induction is so effective at heating a pan up that it's more noticeable. So, like in that top right photo, if you put it on high, you see instantly, that ring where the pan is heating up more than the adjacent, parts of the pan. Um, and so it becomes more visible. And if you do this on a surface like nonstick that can't handle high heats, you can actually get over time, a burn mark on the nonstick, like in the upper left photo. Now, the solution to this problem is, well, if you have a cooking vessel that's 8 inches in diameter, then you pick the emitter on your stove that is at least 8 inches in size, so that the coil can heat the full diameter of the bottom of the pan. Duh. Uh, but if you don't do that, then what you can do is you can get a thicker bottom pan so that the metal in the pan can distribute the heat from just a spot to the entire bottom. So that's one a good solution. Another solution is there are now induction cooktops that have not just a single coil or emitter for each so-called like cooking zone, but that they have an entire grid of coils or emitters that are each kind of small. And so then whenever you can put your cooking vessel anywhere on this surface, and the electronics will detect where the pan is and turn on, the five or six or whatever number of emitters that are covering the bottom of your cookware. And then therefore you now have multiple coils heating up the bottom of the cookware. And as a result, you get very even heat delivery to no matter the size of the cookware, so that you don't have to necessarily choose, an 8-inch bottom pan and then try to, remember to put it on, that burner that's or emitter that's big enough to fully cover the bottom. You can put it anywhere on this what's it called, like uh, cooking surface that has an entire grid of induction emitters. It's a pretty expensive technology. There's not that many induction products on the market with this kind of grid type setup. Honestly, like I've cooked, 1,700 days on my induction cooktop, and I cook on the largest coil on the induction, and I don't really have a problem. If you cook on the largest the coil, um, then I don't have pans that are humongous, and so they all um, will work and get pretty even heating on the largest emitter on the cook surface. Now, the largest emitter actually will struggle to sense a very small, saucepan, and so then I actually do then use the smaller coils for those smaller pans and pots because the large coil can't actually sense the small pan. So that's the only time I use the smaller elements on my cooktop. Now, pricing, it's commonly cited that induction is very expensive. Well, the price maybe 10 years ago was very expensive, but as of the last, 5 years that I've been tracking induction, it's actually not that much more than a similarly quality gas range or electric resistance range. Um, I say similar quality because, like, with electric resistance ranges, you can get the slumlord landlord special that is super cheap and super low quality for less than 798, for example. But then now you're not comparing apples to apples. So we're talking similar quality range. Then, and the only difference is the cooking technology on top. Um, then the price is actually not that much more. And I would argue that, for, $250 more, um, it's worth the additional safety and control and all the benefits that were previously mentioned for induction. Um, Now, some say, well, the this is the low price induction. Like induction easily gets more expensive than a little bit over $1,000. You can easily go 2,000, $3,000. Well, that's true for electric resistance and gas ranges too. Like you can get easily, if you go into a high-end kitchen appliance store, find a $5,000 or $10,000 gas range too. So I think the price range for induction and gas and electric, there are products all over that price map. But when you go down to the affordable end of the spectrum, the price delta is not that big. Now, these all metal induction, this has been a technology for over 10 years in Japan. Panasonic and Hitachi both make products in Japan that can handle all metal. And so here in North America, Panasonic is the only company I'm aware of that has a product that is available here in the US. It's very hard to find. Normally, they only try to target and sell this to restaurants. It also uses 240 volts, and so if you want this, you're going to need to either be able to wire a dedicated circuit for it yourself or get an electrician to do it for you. Um, Being hard to find, I've looked for 5 years on Facebook Marketplace, Craigslist, and eBay. And, about a year ago, I actually got my hands on one at a decent price. And so I've been cooking on this all metal induction, and I can tell you it really does work on aluminum and non-ferromagnetic stainless steel and copper pans. And it works pretty well. So I look forward to this technology um, spreading from a single emitter kind of portable um, induction to being like a full like four emitter cooking cooktop or cooking range. Um, this thing is fairly large because the power electronics needed to achieve the very high frequencies to reduce that skin depth in copper and aluminum pans to a small enough size that you can get decent heating. Um, that power electronics is kind of bulky, but every day people are researching better power electronics that are higher performance and more cost effective because electric vehicles and solar inverters are probably the two primary drivers of this power electronic research, in addition to um, high voltage DC on the grid side, researching power electronics. And so it's a matter of time till, the power electronics to achieve this very high frequency alternating current switching becomes small enough and low enough cost that, this all metal um, technology becomes more popular. Um, some key researchers, maybe to keep track of, are a number of people at Oak Ridge National Laboratory. I put their names at the very bottom. You can, Google their name and, every 6 months or a year, Google their name again to see if they've released any new research on this. Um, there may be other researchers, but these are the ones I'm aware of. But like I said, the current technology is pretty good, but it can certainly come down in price and become more available than just one product on the market. Another commonly cited con to induction is that they don't work well with woks. There are flat bottom woks that work well with any induction, but if you truly believe that the only that's a true wok is a round bottom wok, then they do make round bottom induction emitters. Um, and they're not that expensive. So for $100 to $200, there are induction emitters that are round bottom that can fit a round bottom wok. Um, and then these woks, as they said with most inductions, they put all the heat energy into the metal of the pan. So as a result, your wok, if it's an 1800 watts induction, you get pretty much all 1800 watts going into the wok. So that means that they do heat up very quickly. And if you want like restaurant quality, heating, a very, very high heat in wok, you can, again, for a little bit over $200, get one that is 240 volts that generates more than 1800 watts. And of course, you need an electrician or the skills to be able to wire up a special plug for that, very high powered 240 volt unit. And woks are induction woks are commonly used in restaurants. Panda Express is using induction woks in their kitchens, and being the America's most popular fast Chinese Americanized Chinese restaurant. If they're making this choice to go induction, then it really goes to show that the technology is fully mature and effective. Um, this is another kind of new technology in the world of induction, integrating batteries into cooktops and ranges. And the primary, selling point of this is not to cook while the you have a power outage, but that is certainly a byproduct of this benefit of this integration of the battery. The primary market for integrating batteries into cooktops and ranges is so that it makes it easy for people coming from a gas cooktop or range to jump over to induction without spending thousands of dollars to have an electrician run a new circuit. It's actually not terribly expensive to have an electrician run a new circuit in a typical home. But if your circuit breaker panel is 100% full and then you need to add that new circuit, then it becomes very expensive to upgrade the circuit breaker panel. And then if you only have like 100 amp service for your home, and then you also need to not only upgrade the circuit breaker panel, but also need to get Portland General Electric or Pacific Power to come and upgrade the service entrance wiring to your home, then that gets even more expensive. So if that is the case, then maybe it actually is not too expensive to go with these 120 volt plug-in induction ranges and cooktops. Uh, they are currently at $6,000. So in my opinion, they're kind of expensive, but it depends on what type of appliance you're looking at. If you're looking at Miele's and Garlands and Thermadors and stuff, then maybe 6,000 is quite a normal price for a cooktop or range. Um, it's some other interesting things. So these things, the battery size is sized so that you can cook Thanksgiving dinner or Christmas dinner and not run out of battery. So how they work is they have a battery that lets you cook at maximum like 4 hours of continuous cooking before they run out of battery. So that means, unless you're trying to be a restaurant in your house, uh, there's enough battery capacity to cover even your heaviest cooking day. And so these units have very high powered induction emitters, and in order to not stress out the household electricity, when you cook, they draw the energy from the battery, and then when you're done cooking, then they spend the next hour or two or whatever is needed to recharge the battery slowly. And that's how the battery is buffering that high energy use during cooking. Now, induction noises and buzzing and hums in cookware, it's kind of a complicated phenomena. So what's going on is it certainly depends on the cookware, but if you have multi-ply cookware and the plies are not well bonded together, then multi-ply cookware, you might have an aluminum layer, a copper layer, and a stainless steel layer. Now, note that like the traditional induction cooktops, they're only heating up the ferromagnetic layer. So typically that means it's the ferromagnetic stainless steel layer in these multiply cookwares. And so when that layer heats up, then you can get differential heating. So when that layer heats up, then the aluminum and copper layer they heat up only because they're touching the ferritic stainless steel layer, and so that heat transition maybe not super immediate, and so there's differential heating, and that causes the layers to vibrate against each other, and that might generate some noise. If you have a multiply cookware that's the layers are really well bonded together, that is not a problem. Same thing, many cookwares have a like for example an aluminum cookware, but then in order to make it induction compatible, they then um, bond a stainless steel disc to the bottom that is ferromagnetic, and so that disc in the bottom, depending how well it's bonded to the aluminum cookware, if it's not that well bonded, then again that differential heating can cause some vibrations. And then the other thing is if you put like a 12-inch wide pan onto like a 6 or 8 inch induction emitter, then if you turn it on high right at the beginning, then it can heat up that inner, 6 or 8 inches very quickly, and then that results in differential heating on the pan bottom, and that can result in some warpage that is generally not permanent. Like the metal, when it cools down, will become flat again. But during the heat up process, you can get some vibrations because now the pan is not sitting flat against the glass surface, and then that results in some noise. So there's some solutions to this. One is, play around with different cookware, uh, and because there are many cookwares on the market that don't have noise problems when used on induction emitters. The other solution is to not jump straight to preheating your pan on the highest setting. Um, preheat your pan at like, setting 5 or 6 if it's you have a choice of 10, just right in the middle. And then only when you are you ready to actually cook, then jump to like, 9 or 10 if you need that heat level. Now, when I say different quality cookware, there's actually not a strong correlation between price and quality. So, like, you just have to play around with the different cookware. There's plenty of internet on Reddit and YouTube and other, places where people can provide, user feedback to their experience, to help you do your research and find out which pot and pan, is very quiet on when used on an induction cooktop. So some things to note is stainless steel. Stainless steel is an interesting metal. There's actually many different types of stainless steel. The stainless steel that you can stick a fridge magnet to the bottom and it will actually stick is a ferritic stainless steel, or most commonly 430 stainless steel is what's called. Um, that there's quite a few stainless steel cookwares out there that use ferritic stainless steel, and so therefore it's natively compatible induction. But there's also a lot of stainless steel out there that uses uh, authentic stainless steel or 304 stainless steel. The reason why 304 stainless steel is quite common is that it's very rust resistant and corrosion resistant. But that stainless steel is not natively magnetic, and so it's not compatible with induction unless the manufacturer bonds a layer of ferritic stainless steel or bonds a disc bottom to it that is ferritic stainless steel. Um, so something to note on stainless steel, um, that there's different types of stainless steel out there. And then the other thing is when you're interested in induction, don't start your journey with induction using like a really cheap induction single emitter cooktop from Amazon, for example. The power electronics on these super cheap induction cooktops is really bad, and so they generally make quite a bit of noise. Whereas actual like cooktops and ranges that have 4 burners um, don't have that noise problem. Induction reliability. Uh, People say that induction is not as reliable, but that's not really the case. In my experience, when I lived in apartments, I had to change out electric resistance elements out of electric stoves because they self-destruct due to the heat and boilovers and stuff getting into the contacts of the electric resistant elements. And then when I had a gas stove, the electronic ignition system failed way before anything else on the gas stove failed. And I think the high heat from combustion results in contamination and corrosion that self-destructs the electronic ignition quickly. Versus I'm 1700 days and my induction has been problem free. So, I think by not getting super hot, the induction doesn't self-destruct as quickly. So I think they're quite reliable. And so if I think with induction, if they don't have problems within the return period of your appliance, then they're probably not going to have problems for thousands and thousands of days down the road. Induction, kind of like anything else in your home, it's now our homes have more and more electronics, whether it be our heat pumps have inverter boards, and washing machines have lots of power, have lots of electronics. It's just a good idea now if your home does not have a surge protector inside this circuit breaker panel to get one and have somebody install it, because this will protect not only your induction, the power electronics and induction cooktop range, but everything else in the home. Charring without a flame, as I said, like if you traditionally char with an open flame or right on the electric resistance heating element. You can do it in a broiler instead and achieve very similar results. And then induction, people who come from gas like physical knobs, and then complain about the lack of physical knobs in induction. Well, there's quite a few models of induction products that have physical knobs. It's not as many as gas, of course, but there's still quite a few choices. And so if you look on the market for this, you will find it. And there are models that are not super expensive. So it's out there. So don't think that this is a barrier. So in conclusion, there's really increasingly less and less reasons not to upgrade to induction for cooking. Like I said, we've covered the barriers to entry, and as I have articulated, many of those barriers to entry are not really a barrier anymore, and so can't use those things as an argument anymore. And so, to recap the benefits induction, here, in my opinion, the top highlights: the better indoor quality, increased safety from burns and fires, increased safety from not having gas in the home, faster heating and better heat control, much easier to clean, and more energy efficient. So if that concludes. If you like this presentation and the work that Solar Oregon produces, whether it be the solar home tours and peer-to-peer events, you can support us with this link. And for upcoming events, we have a webinar on August 11th at 5:30. It's a how to go solar plus storage. So if you have friends and family that are not that knowledgeable about solar and want to learn more about solar, this is a great 101 presentation. If you missed the August 11th presentation, we have many other offerings of this solar plus storage event. September 6th, there's a webinar on portable and window heat pumps. So if you are a renter and you want a heat pump, these are really good solutions. Keep that calendar for this. This is a picture of an example of a window heat pump that you can just slide it into a window and take it back with you if you move out of a rental and use it for your next rental. So kind of very interesting product. And then October, there's the Go Zero Home Tour and Sustainable Building Week. So it's one of our Solar Oregon's largest events of the year. So keep that date open. More details will be coming. November, there's a webinar on cottage clusters. And in December, there's a webinar by the Citizens Utility Board on understanding energy rates. So with that, let me check the Q&A. Let's see, view Q&A. Okay, efficient. Okay, so energy efficiency is an interesting one. So with electric resistance, if you have a, let's say like 8-inch diameter emitter and you put a 10-inch diameter pot directly on it, the efficiency of electric resistance is fairly high. Um, Now, the problem with electric resistance is that often if you have like a 6-inch uh, pan or pot and you put it on an 8-inch diameter emitter, then the outer you lose a lot of the heat because the electric resistance can't um, put all that energy from that's not being covered by the pan into the pan, and so if you have the perfect condition where you have the right perfect emitter to the right size cooking vessel so that you get full coverage, then the difference between induction and electric resistance inductions may be like 10% better. So not a huge difference. But if you have a lopsided sized emitter to the cooking vessel, then induction can keep that high efficiency because it'll auto size to the pan versus your electric resistance glass top or electric resistance heating element cannot auto size to the smaller pot. And so in those cases, then the difference in efficiency is much greater. Um, so uh, 10% is commonly a cited figure. So like, increased energy efficiency, if you're talking just purely at the cooktop, um, in ideal conditions, it's not that big of a difference, but in sub-ideal, then you can probably get, you know, 40 or even 50% better because of the depending on how lopsided your pan is. Um, and then the other thing that's not really considered is the air conditioning energy savings. So often it's that's not accounted for in these percent energy savings. And that's kind of hard to measure. And then in the wintertime, maybe it's actually desirable to have some waste heat come out of the gas or electric resistance cooktop to help reduce heating energy usage. But if you have a heat pump, that it's actually more efficient to heat your kitchen up with a heat pump than it is to heat your kitchen with residual heat from your cooktop. So, um, you know, that's the answer to that question. Um, let's see. Are there other questions? Let me look. Uh, that looks like it. We don't have other questions. Again, you can email info@solaroregon.org if you have additional questions. You can also find me on LinkedIn to ask questions. Oh, we do have another question. What standard sizes are available for countertop units? Um, so 30 inch and 36-inch are the most common countertop and slide in freestanding induction cooktops and ranges. Uh, if you want something besides uh, 30 and 36-inch, then there are fewer options available. Um, like for example, like 24-inch, they do have 24-inch for like, apartments and RVs and stuff, and there may be something beyond 36-inch too, like 42. Okay, let's see. Other questions? Okay. Well, there may be no more questions. Oh, nice presentation. Thank you. Okay. Yeah, with no more questions, again, keep these dates free on your calendar and look forward to the Eventbrite link. You can search Eventbrite Solar Oregon, and then you're going to find on the first hit on Google the Eventbrite page for Solar Oregon to sign up for these webinars. Um, and then look forward to Eventbrite for the in-person Go Zero home tour in October. Okay, with that, we're going to close out this webinar, and I hope you guys have a great rest of your Saturday.